All right, today we're jumping into a really serious vulnerability that hit the absolute core of Microsoft Azure, CVE 2026-24304. And trust me, when I say serious, I mean it. Let's dig in. So first things first, look at this number, 9.9. On the CVSS severity scale, which only goes up to 10, that is, well, that's about as bad as it gets. This isn't just a minor bug. This is a full-blown, sound all the alarms kind of problem. So what does a 9.9 score actually mean? Officially, it's what's known as an elevation of privilege vulnerability. And in plain English, that means a flaw that could let an attacker, someone with just a tiny bit of access, basically climb their way up the permission ladder until they have total control over an environment. And its target? The absolute heart of Azure.
So what exactly was in the crosshairs here? This is the scary part. We're not talking about a single virtual machine or a database. Nope. This vulnerability aimed right at the Azure control plane itself.
The target was the Azure Resource Manager, or ARM, as you probably know it. Now, you can think of ARM as the air traffic control tower for your entire Azure setup. It's the central command center that handles creating, updating, and deleting pretty much everything. So, if an attacker gets control of ARM, it's not like they've hijacked one plane, they've basically taken over the entire airport. And the root cause for all this? It's a classic fundamental security flaw, CVE-2026-24304, improper access control. It's really about the system failing to double-check if a user should actually be allowed to do something. You know, it's like a high-security door with a broken lock, letting just about anyone wander right into the command center. Okay, so we know what it is and why it's so bad. But how would an attacker actually pull this off? Well, the entire story is kind of hidden inside the vulnerability's technical fingerprint, the CVSS vector string. Now, it might look like a bunch of gibberish, but it tells you everything you need to know.
Yeah, this thing right here. This string of letters and colons isn't just random code. It's practically a recipe for disaster. Each little piece tells us something critical about how an attack would unfold, from where the attacker is sitting to the kind of damage they can do.
Let's break it down real quick. AVN means the attacker can be anywhere in the world. PRL means they only need low-level privileges to start, just a foot in the door. And this is a big one. UIN means no user interaction is needed. They don't have to trick anyone into clicking a bad link. The whole thing can be automated, running silently. Then you have scope changed, which means they can break out of their initial little box and take over the whole system. And the impact? High, high, and high. Total compromise. Put it all together and you have a genuine nightmare scenario on your hands.
With a threat that severe, the next obvious question is, what's the fix? How do you even patch a vulnerability that's woven into the very fabric of the cloud itself?
And for every single person running workloads on Azure, the most critical question is, what do I need to do right now? What do I have to patch? What configurations need to be changed to keep my environment safe? And here's the answer, directly from Microsoft, and it's pretty surprising. No customer action to resolve. Nothing. You don't have to do a single thing, which of course immediately makes you wonder, wait, why not? How does that even work? The reason is that this was an exclusively hosted service vulnerability. The flaw wasn't in your virtual machine or in an application you deployed. It was deep inside Microsoft's own infrastructure, the machinery that actually runs Azure. So Microsoft's engineers found it and fixed it completely on their side. The CVE was then published mainly for transparency to let the world know that this vulnerability existed and, more importantly, that it was fixed.
This entire episode, from that critical 9.9 rating all the way to the no action required resolution, leaves us with a really powerful takeaway about modern cloud security.
And that lesson is this. We spend so much time and energy securing our apps and our data, but the security of our entire cloud environment really hinges on that invisible management layer, the control plane. A vulnerability there, like this one, simply bypasses all the other defenses you've so carefully built.
So as we wrap up, this whole incident is a powerful reminder of the shared responsibility model in the cloud. We are responsible for securing our workloads, but we have to place an enormous amount of trust in our provider to secure the control plane. This time, Microsoft caught it and the system worked. But it leaves all of us with a lingering question we should be asking. How secure is the brain of your cloud?